Working with 5-axis terminology, Part 2, From and Towards a Point. So firstly, let's look at a definition for using a point to control our 5-axis motion. From a point is where the tip of the tool is constantly pointing away from a predetermined point regardless of its angular tilt. In the first picture we can see that if you struck a line through the direction of the tool, it would constantly strike the centre of the point, whilst the tip of the tool is always pointing away from that point. Towards a point is the opposite. The tip of the tool is constantly pointing towards a predetermined point, regardless of its angular tilt. In picture 2, we can see that if you struck a line again through the direction of the tool, that line would strike the centre of the point, whilst the tip of the tool is pointing constantly towards that point. So let's look at some programming examples of using a point. I'll be using Autodesk PowerMill to do this. So we're going to start with programming from a point. So here we have a standard 3-axis toolpath, and the feature we're looking at machining is this bore feature here. What we'll notice about this feature is that it's undercut, so we have to project our toolpath underneath that undercut so that we can access the surface. So to do this, we're actually programming using a surface projection toolpath, which is an interesting toolpath strategy in itself. And the way this works, if you've never used it before, is we take a surface just like the blue one highlighted there, and the toolpath will use the flow of that surface to project the toolpath, and wherever it hits, that's where the toolpath will be created. There's a lot more that we could say about surface projection toolpaths, but for now we're going to be focusing on programming from a point to control our 5-axis motion. So I'll just turn that projection surface off. So as we simulate this standard 3-axis toolpath, you'll notice again that as we get down so far, we'll begin to get an interference and collision with the holder. We just shade that up so that we can see it more clearly. You can see that the holder is ploughing into that corner. Another way around this would again be to extend the cutter, which would reduce rigidity and also reduce the quality of our surface finish. So we can use our 5-axis machine to tilt the tool, and we can do that in this case by using a point. So this toolpath here uses a point to control the motion of the tool, so that the tip of the tool will strike constantly through a point. So let's look at the settings for this toolpath. So under our tools axis, from our pull down menu, we've selected from point, and from our work plane we have placed positions at x0, y0, z80. When we draw the tool axis, you'll notice the point is now highlighted on the screen just here. So the tip of the tool will remain constant through that point, pointing away from the point, and that point will anchor the movement of the machine. So let's simulate that to see what that looks like. So we can see that the tool is constantly looking towards that point. Well, sorry, is constantly looking away from that point. at the tip of the tool. So the angle will change as we go down that wall. As the tip gets further away from that point, the angle will change to the point where as we come across the floor, we're almost reaching a vertical angle as the tool constantly tracks that point. So that's programming from a point. And typically, programming from a point will be used to program internal features, such as bores and pockets. And this is a very good application for from a point. But others can be used. Let's have a look at how the automatic collision avoidance operates and simulates as we program this same feature. This is one of the things that PowerMill Autodesk have introduced, which is really taking it a step further, where we hand the process over to PowerMill to control the movement and the required movements to miss the collision on that holder. So our tool axis is set back to vertical. We've selected our automatic collision avoidance, and under collision avoidance we've told the machine, or asked the machine, to default to lean. We've asked the machine, or PowerMill, to work with a 1mm envelope of collision against the holder and shank to machine that feature. Let's see how that simulates. So we'll notice again that we stay vertical until needed. Then as that holder gets closer to the component, we see the necessary lead angles introduce so that we get that 1mm collision between the holder and the component. We'll notice again that as we come to the floor area, we can begin to move towards a vertical approach, because there will be a point on this feature where, being vertical, there will be no collision with the holder. This is where our automatic option now is far superior to working from a point. The great thing about that option is you can tick a box and hand the whole process over to PowerMill, and it will work out the most optimum solution for you. So again, here's another example of working from a point, and that is to machine this pocket here. Exact same scenario. We have a 3-axis toolpath machining that pocket, but when we come down to the lower end of the pocket, the deeper part of the pocket, we'll notice again that we will begin to see that the holder will begin to collide. If we select that pocket, just keep those surfaces. Just keep those surfaces by pressing Control K. We've got another one there. So when you select surfaces, you can press Control K to keep, Control J to hide, as in junk, and it's Control L to bring them all back again. So we're going to do a Control K on there just to help us visually see what's happening here. So as we simulate from there, you'll notice there comes a point where again the holder collides. And this is a good feature to use from point. And again, we could just tick the automatic box, but for this purpose, to explain the principle of working from a point, this is a good feature to demonstrate. So again, let's look at the settings for working from a point. We've put the point this time at the center of our axis. It's 0 in the X, 0 in the Y, 0 in the Z. So the tool will constantly point away from that point and use that point to track the orientation of the tip of that tool. So what we'll see is that as we machine around that pocket, we've got a constant angle that's being driven by a point at the center of our work plane there. So that's working from a point. Excellent. So let's bring the rest of those surfaces back, which is Control L. So let's look at towards a point. So we're machining this outside surface here. If we were to machine that in the vertical orientation, we would reach a point where the holder would collide with this edge. And we'll simulate in a moment what automatic option looks like and what PowerMill does when you hand the process over to it. But for the purposes of demonstrating towards a point, let's look at the settings on this toolpath. So under tool axis, we're now selecting towards a point. And if we turn off the model, we will see that 0, 0, minus 200, we can draw our tool axis point. And that's the point that now the tip of the tool, instead of working from that point, pointing away from a point, it's now going to constantly point towards a point. And typically this strategy will be used for external features, for external bosses and solids. So let's see what that simulates like. So we'll see that as the tool goes round that feature, it is constantly looking towards this point here, giving us a constant tilt away from the component. So that as we get down closer to that collision corner, that tilt is giving us a safe condition. So that's typically how we apply working towards a point. Machines down the wall and around that floor. This strategy is an optimized constant Z strategy. So we can apply any of those finishing strategies, but select the tool axis to work towards that point. So let's have a look how PowerMill applies the automatic option. This is always interesting to see how PowerMill will introduce the necessary angle at the right time to avoid the collision avoidance. So again, under tool axis, we've put our tool axis options back to vertical, selected the automatic collision avoidance, which throws up that collision avoidance tab. We've asked PowerMill to default to a lean option, and again work to a 1mm collision envelope. Let's simulate that to see what that looks like. So again, PowerMill stays vertical because it can do at this stage. As soon as it begins to see the 1mm collision envelope against the shank and the holder, we will notice that PowerMill introduces the necessary tilt angle to avoid that component, sorry. As soon as it's missed that corner, and whenever is okay to do so, we're almost back to vertical, because it can do that around that floor area. So introducing that automatic tick box really almost does away with the need to use from a point or towards a point, but there definitely will be situations where working from a point and towards a point will be the best option, even over using that automatic tick box. So again, if you're new to 5-axis machining and this is your first look at 5-axis terminologies, I hope that you found that useful. So that's working from and towards a point.